This toolkit looks at two quadratic function transformations. The first one, the effective h, when we are adding or subtracting something from the x inside the parentheses, and then the effective k when we're adding or subtracting something outside of those parentheses. In this first example, x squared, f of x equal to x squared, is this parabola right here in the middle. Now I'm going to identify what happens when I subtract a number from x and when I add a number. So when I'm subtracting h, I expect that I move the graph left, and this is where we have to remember it's the opposite of what we think. So this moves the graph right. When I'm adding something, I expect to move the graph right, so I need to remember, oh, it's the opposite of what I think. I move the graph left. So we can go ahead and identify these two functions below. So the graph g of x equals x plus 3 squared. This is a plus. We're expecting to move right, but in fact we are going to move left. So when we add something inside the parentheses, we are moving left. When we subtract something inside the parentheses, again, we expect left, and it does the opposite of what we think. This is transforming the graph by shifting it to the right. So the effective h is left and right in the opposite direction that you would expect. For the effective k, this is going to be up, down, and exactly in the way you would predict it. So when we have x squared plus k, that's going to shift the graph up. When we're subtracting a value, we are shifting the graph down. In this graph that's shown, the middle one is the graph of the parent function, f of x equals x squared. J of x equals x squared minus 3. This is going to be a case where we move the graph exactly the direction we would expect. We shift the graph down. For k of x, again, what we would expect, k of x equals x squared plus 2. This is a graph that is shifted up.